Hi all, welcome to the day 2. In day 2 we will be covering deployments, services or the load balancer, volumes, config map and secrets. Coming to deployments, so deployment provides a mechanism for auto healing and state management. So what do you mean by auto healing? Let's say one of the container or the pod goes down due to some error. So it should restart automatically. The auto healing provides that feature. It auto restarts the container if it goes down. Next is state management. State management makes sure that, let's say I want 5 instances of Nginx running at a time. So I specify like I need 5 replicas of Nginx. So the state management automatically ensures that 5 are running at a time. Let's say if one goes down, it automatically restarts another one and makes sure that the state is 5. So deployment internally uses replica sets. Replica set is a type of resource and that maintains the expected state. In replica set, we specify I need 5 instances of Nginx, so it always maintains that state. Let's say 2 goes down, it automatically restarts another 2 instances of Nginx. Next is deployments can contain multiple pods. We'll go through a deployment.yaml file. As usual, it's better to go with the official documentation of Kubernetes instead of by hearting the template of deployments. So Kubernetes deployment, search for it, you get the base template here. So fine, I copied it and let's go to the terminal. Clear, and I have tested it before, so kubectl delete -f and deployments.yaml file. Okay, so more of deployments. Okay, I'll create a fresh file, deployments.yaml, and I'll paste the contents of it. So here I'll set the number. So we'll go through the important parameters that are present in the deployment. One is the kind I specify as deployment, but in this file we'll start from the bottom. So deployment spec is having a parameter template, and in that template I'm specifying the label of template as app nginx. You can see template metadata label as app nginx. So the template name will be app nginx, and the template will be containing the containers nginx, and the image will be nginx latest. Nginx latest and ports port 80. Okay, so deployment is internally having a templates property, and we are setting the label of template as app nginx, and the template will contain container nginx latest. Okay, now we'll move up a little, one level up in the YAML file. So deployment spec is having a property called as replicas. Here I specify I need 5 replicas of template matching the label app nginx. Match labels. So match label looks for the template containing the label app nginx. So here match label is same as the template name, so this both will get matched and 5 instances of this template gets created. Most important thing is the template label and match label should be same. If they are not same, then it won't be able to create 5 replicas the template. Okay, let me save it, and as usual kubectl apply -f deployment.yaml file. So it created the deployment. So kubectl get deployments. Now we'll run that. You can see there is an nginx deployment Out of 5, 5 are ready, 5 are available. Okay, kettle and get pods. You can see 5 deployments of Nginx are running. It's awesome, right? I mean, with one command you created 5 instances. Let's say if you want 100, you just change the replica set to 100. Now let's look at the replica set to kubectl get replica set or rs. You can see there is an Nginx deployment. The desired is 5, current we have 5, ready is 5. Okay, now let's try deleting a pod and see whether auto healing is really working or state management is really working. So let me delete the 2df8h pod. So kubectl delete pod and I specify the name kubectl delete pod. And let me paste it here. So I'll be deleting the pod. Now let me check. So it restarts another container. You can see, right? It deleted, but it restarted another container. So that is the state management. You can see now all 5 are running again. So how do I delete the pod? You can't individually delete the pod. All you can do is you can delete the deployment. So we have the pods and I deleted every pod. Let's see how I can delete the deployment. Delete deployment and deployment.yaml or delete -f deployment.yaml. So if I do that, it deletes the deployment. Now if we check the pod, if you delete the deployment, it automatically removes the pods also. So get pods, you can see there are no pods remaining. It removed all the pods too. So that's it with the deployment. Yeah, we'll see about services in the next section where we add networking to the deployment. Now we will go through the next section, service or load balancer. So load balancer or service is used to provide networking to the deployment or acts as load balancer to the deployments. Service is used to add network to the deployed pods. In real definition, it's an abstraction to help you expose group of pods or deployments over a network. So service type. So coming to service type, we have 3 types of services. One is ClusterIP, Node port and load balancer. So ClusterIP is a default service type. So primarily used for internal communication within the cluster. Let's say you want to communicate, you want to establish communication between pods, then you go for the ClusterIP. Pods within a cluster, then you go for the ClusterIP mode of networking. Only accessible within the cluster network. You won't be able to access it outside of the cluster network. You basically can't access it from the local host or from outside the local host. So coming to IP assignment, it allocates a virtual IP within the cluster. You won't get external facing IP address when you're going with the ClusterIP. So services that are only consumed by other services within the cluster. This is most important. Let's say there is a service that requests connection to database. Then the connection between database, the database might be exposing a ClusterIP so that it can be only accessible within the cluster, not from outside. But at the same time, it can be accessed by the pod that is present in the cluster. Internal load balancing. So that's another use case of ClusterIP. So when you are seeing ClusterIP, this should be your primary thought. Like it's used for internal communication within the cluster or port to port communication. So ClusterIP will be like port to port communication, not for external communication. Port to port internal communication. This should be the thought that come into your mind. Port to port internal communication. Node port exposes nodes in the cluster. So this is used when you want to access the service within the cluster as well as from outside the cluster through a port. So allocate static port on each node. And so the use case of node port is services that needs to be accessed from outside the cluster but do not require a public IP address. So it's an example of simple load balancing. So you will get an internal IP address, but you won't be getting a public IP address, but you will be able to access it from outside the cluster. In our demos we will be going with node port because this is local host access. So whenever you are seeing node port, the first thing that should come into your mind is local host access, and node port is used for testing primarily. So and the services can be accessed from outside, but most likely for testing purposes. And next thing is load balancing. So load balancing is an enterprise setting of services. So the purpose is to expose service to network or expose service to internet or a corporate network. IP assignment, when it comes to IP, creates a load balancer in the cloud provider's infrastructure and assigns a public IP. In load balancer setting, you will get a public IP and you can access the service from anywhere in the world. So the use case is services that need to be publicly accessible. So let's say we have Netflix.com, so it will hit the load balancer service first, then the request gets internally routed to the deployment or the pod. So advanced load balancing features like affinity, session affinity, health checks. So load balancer is an advanced setting, and you will be using load balancer in enterprise grade settings. So to show you a demo of the services, so we will be going with node port because we can access it from the node port or from the local host, and this is mostly used for the testing purpose. Or simple deployment, you go for the node port. This is not the preferred way of deployment due to security concerns. Still, for testing, this is a variant of services in Kubernetes. So we'll, as usual, we'll go and search for the services in Kubernetes. And so services, we'll search for service.yaml example in Kubernetes, and we will get service documentation. So here you go, you copy the first available template, copy it, come back to the terminal. So terminal will create a service.yaml file. Paste it here. So here we will go through the important parameters. One is a kind is of service, and you specify the name as my service. Here you are providing a selector. You have seen the selector, right? This selector should be same as the template label that you provided in deployment. So let me do one thing. Let me cat deployment.yaml file. So here the template label is app-nginx. So this should be matching to the service selector. So let me deploy this deployment-f deployments.yaml. So it created the deployment. This is a label app-nginx vi, and the name is service.yaml. deployment.yaml, copy it, paste. So kind is service, name of service is my service, and let me change the selector. Selector is app nginx, and I'm specifying protocol TCP 80, and target protocol is, let me check one more second, app nginx. This label should match service.yaml selector app nginx, so that is same. Next thing, what we need is a node port, so we'll be searching for node port. We can see node port example. We need to copy this field. What you need to do additionally is, okay, instead of this, let me remove the service.yaml, vi service.yaml. Let me copy this. So service, the selector is app nginx, the type of service is node port, so app nginx, the port that the container is running is 80, the target port is 80, and the port that you want to expose, the port that you want to expose to the local host is provided in node port, so it will be exposing to the port 30,007, and it should be in the range of 30,000 to 32,767. So you save it. So we'll again go through the service.yaml file. Kind is service, you provide the name of service, you specify the type of service as node port, which is localhost, nothing but localhost. Selector as app nginx, this should be same as the one that is present in the deployment.yaml file, and you specify which port it should be looking for and which port it should target to, and the node port to which it should be accessible from the localhost. So here the localhost is accessible from 30,007. So let's save it and kubectl apply -f service.yaml file. You start the service. So kubectl get service can be also called as svc. So you can see there is my service, and the node is of type node port, and the cluster IP is 10.43.9.175, and it is exposing the port 30,007 to the local host. Now we can see that the service is running on the port 80 and 30,007. Since we are running in K3D, you need to do an additional step, that is port forwarding. So let's do the port forwarding. This is a command to do the port forwarding. Here we are forwarding my service running on port 80 to 8082. So if you do this step, the ports, whatever request is coming on port 8082 will be forwarded to port 80 inside the cluster. So let's paste it. So it's already forwarding now. Whatever comes to 8082 will be forwarded to 80 inside the cluster. So let me run localhost 8082. You can see it is serving the page nginx, and this is coming from the deployed service. So that's one, and let's stop it. Now let's see how to access nginx from another deployment or another service. So let's copy this. So I'll create one Ubuntu deployment. So ubuntu.yaml, and I'll paste the content here. So I'll create an Ubuntu deployment, Ubuntu container, and let kubectl apply -f and ubuntu.yaml. So it creates a ubuntu.yaml file, creates ubuntu deployment. Now let's get into the ubuntu pod. So you can see there is one ubuntu pod. So let's get into it, exec into it. So exec ti ubuntu deployment, and let me bash into it, ubuntu deployment and bash. So clear. So once I do env, you can see my port information is already present inside or already injected into this container. My service pod, my service TCP protocol, my service load balancer address. So let's do one thing, let's do curl of my service. Okay, curl is not installed on this container, so what we need to do is apt update, we wait, apt install curl -y. And now let me do curl my service. You can see it is able to connect to the nginx and retrieve the HTML file. So you can access other services from the deployments too. So all this works because of the internal load balancing that we mentioned before. That's it with the services. That's how you connect from one service to another service, or connect from one deployment, one port to another service. And this is how we do the port forwarding. Yeah, thank you. In this section we'll be covering config map. Config map is very useful and it is very simple also. So config map is an API object which is used to store non-confidential data in key value pairs. This is the most important term, non-confidential data in key value pairs. Basically it's a dictionary that can store non-confidential data. So pods can consume config maps as env variables or the environment variables. Config maps allow you to decouple environment specific configuration from the container images. Let's say you have a deployment file and you don't want to specify the database user, then a config map is a way to configure it at the runtime. Now let's see how to create one. So kubectl, you can see from literal, this is how you create the config map through CLI. So you need to provide this command kubectl create config map, some config map name, and you provide the key value pair from literal key value. Okay, so this is an example. Here the config map name is my config. So let's see, let's create this and let me open the terminal and ls. So let me create the config map, created it. Now let's see, get cm, let me see, you can see my config is there, my config map is there. And then if you want to see the content of config map, then you can specify get cm my config -o YAML. You can see what all are the data that is contained in the config map and when it was created. So we have two values, two key value pairs. One is database host, other one is database port. So that's how you can see the content of config map. We have seen at the end we will see how to create one from a file also. We can also edit config map. So kubectl edit config map, and config map name, so my config. You can see I can add one more entry here, then we can access it outside. So like database URL MySQL. That's one way to do it. You can see the config map is edited now. Now let's run it again. You can see it's added and it's stored. Okay, so that's one. And next thing that we will cover is we can delete the config map. I'll show these two at the end. Loading it from a file and deleting it. Now let's use the config map that we created inside a deployment file or inside a container or inside a pod. So this is how we add. So we need to specify, I'm using an env, I'm loading an env, and the name of the env inside the container is database host, and I'm pulling the value from the config map key reference, and the name of my config map is my config, and the key that I'm trying to pull is database host. So internally it should have localhost as a env. So let's copy this piece and let's come to our Ubuntu image, Ubuntu container. So here I'll add let me align it properly. Since this is a YAML file, you need to align it properly. So we are good. So we will be able to access the database environment variable inside the container now. So let's save it. Kubectl get deployments. You can see Ubuntu deployment is already running, so I'll delete it. Delete deployment, Ubuntu deployment. I deleted it. Let me start the deployment again. Apply -f Ubuntu deployment, ubuntu.yaml. Now we can see the deployment is created. Let's check the ports. Get ports. We can see one is getting terminated but other is running now. So let's exec into it. So kubectl exec ti, and we need to specify the the port name. Copy this guy, paste it here, and bash. Now let's do an env check, and well, you can see database host is injected as an environment variable to the container. So let me do database host. You can see localhost is here and localhost is here. That's how config map works. It's pretty simple but very useful. So that's how we inject config maps as an env to the container or the environment variable to the container. Now we have two things pending, right? How we load it from a file. So let's do one thing. Let me create another file, test.env, and I can touch, let me do vi itself, vi test.env. Here I call prop1 property 1, okay, db user equal to sa, db password equal to test123. let's have this file. Let's save this file at test.env. Now let's create a config map out of this test.env file. So create config map, okay, my config, my test config, and I need to specify from file equal to test.env, from file equal to test.env. You can see config map is created. Let's kubectl get cm my test config and -no YAML. Now you can see it is having two variables, db user sa and db password 123. That's how you create config map from a file. So that's it, and let's see how to delete one. kubectl delete cm config map. My config map name is test config. Okay, that's it. So we deleted the config map also. Hope it is clear. Pretty simple but very useful, and we use it every day. In next session we'll be seeing secrets. It is exactly same as config map. Only difference is it can store sensitive information. In this section we'll be covering secrets, and secrets is exactly same as config map. The only difference is it can be used to store sensitive data such as passwords, token or a key. Now let's create a secret. You can see command is exactly same as the config map. The only difference is you need to specify the type of secret. So I'm just going with the generic secret here. You can read more about secrets later. So I'll just create a secret, and let me see, strong password. I'll be storing my database password in the secrets. So terminal, and let me do start the password. So secret is created. So now let's see get secrets. You can see there is one secret which is present. So let me try to get the data out of it. Okay, -o YAML. You can see the database password is there, but it is encoded in base64 format. But if you want real benefits of secret, then you want to use the HSM module or some other module that can provide you the additional security. So this is one example. Kubernetes IO/TLS can be used for storing the TLS certificates, the TLS keys. So accessing it inside the container is exactly same as a config map. The only difference is instead of config map key reference, you need to change it to secret key reference. So I won't be showing you how you can access. Okay, let me show you how you can access it inside a container. So vi ubuntu YAML, and we already have the name. Okay, let me add name, and name will be what? Database password. Let me paste it here. Let me align this properly. So it will be able to pull the secret from the secret container or the secret resource. So kubectl apply -f ubuntu YAML. Okay, there is some issue. There's a tab go. Okay, indentation. Okay, the set number 27 is having issue. Now let's start it. Okay, so it is deployed. Clear kubectl -f and ubuntu.yaml. It is deployed, and now let's exec into the pod. Get pods, and kubectl exec ti, and ubuntu container name, paste, and bash. Clear. Now let's check env, and you can see database password, my strong password. It is injected as environment variable from the secret. So echo dollar database password, you can say my strong password. This gets echoed. Yeah, so that's it with the secrets. And similar to config map, you can, but the only thing is you can't edit the secret. This command is not there. You can't edit a secret. If you want to edit the secret, then you need to delete it and create a new secret from it. Next thing is you can create a secret from a file. Generally these are used to load the TLS certificate or the TLS keys. And yeah, now let's see how to delete a secret. So kubectl get secrets, my secret. Kubectl delete the secrets. Kubectl delete secret, since it's a resource type is secrets and resource name is my secret. So it deleted the secret. That's it with the secrets. And yeah, this is helpful whenever you want to provide the credentials to database or user credential to the container. Then we use secrets.